Okay, great. Can everyone hear me? All right, I'm Jim Hughes. I'm with CCRI and Location Tech. Who didn't go to Rob's talk? Okay, a few people, and most of you I recognize. So this talk is about some of the collaboration that Rob was talking about that's happening between the Location Tech projects and some of the things that are coming out of the GeoMesa project as we're an open source effort. And the goal is to generally make things better. I'm obligated to say a little something about GeoMesa. Rob already covered it in a little bit of detail. This is not a complete list of things that GeoMesa is capable of. We've got some integration with MapReduce, input and output formats that lets us have Spark support. We primarily work with vector data, and some of the work that we do can be pushed off on the Accumulo tablet servers. So as you have a Geo server stood up, it's not just good for looking at WFS and WMS. You can make calls to WPS and do remote processing to generate either some sort of heat map or histogram on the fly, and you can pull that back into your actual client that you're looking at. So you can kind of play around and inspect your data in a pretty complete way. Okay, so I don't want to talk about all the things that we can do with GeoMesa. We're going to talk about some of the technology about how we do it. That's going to feed into why we're spinning out this project called SFCurve. That's all about space-filling curves. Eric from the GeoWave project had a chance to talk about some of the details there. Mercifully, this is a 15-minute talk, so I don't have time to bore you guys too much. But to paint some of the big ideas, we've got to answer the question, how are we going to store multidimensional data? And one of the things that we've done really well in GeoMesa is focus on particular use cases, make those fast, and then extend from there. I'm actually a mathematician, so I'm really interested in all the general abstract things we can do, but we've got a big focus on speed at CCRI. Okay, so the question is, if we've got multiple dimensions, how are we going to get it down to one? Space-filling curves is the answer. And as I said, I'm a mathematician. The background here is that about 100 years ago, mathematicians were asking philosophical questions about if I've got the unit interval and I map it into a unit square or a unit cube, can I cover it in some sense? And if you ask a 5-year-old, they're going to say, yeah, watch me just scribble with a crayon. And as a mathematician, we want a more regular way to make sure that we actually covered it. And so we come up with these different schemes. I'm going to call out 3 of them. There is a whole menagerie of space-filling curves you can have. There are some properties we want. We want them to nest so that there are parts that are repeatable in the process. And we want them to be something that we can actually program. So anything that's too particularly crazy may not be good for us. So the first thing we could do is we could go back to Computer Science 101 and say, how do we actually do this? How do we lay out data in disk whenever we have a 2-dimensional array just naively in memory? And we just kind of do the typewriter thing of just write a row, write the next row, and keep going. The thing that you could say is, well, that's going to have really bad locality properties. There are big jumps as we go between rows. So for the z-order curve, the thing you would say is, and someone actually wrote into the Accumulo list and suggested this, we'll take the x bits and the y bits, and once we have a bit representation of where we are in the square, we'll just interleave the bits. And that's all you have to do to code up a z-order curve. My boss actually had a 90-minute workshop that he was giving, and he's like, I'm going to code that up in front of them. And we're like, no one wants to see those details. The Hilbert curve is a little bit more fun since you have to keep track of these rotations as you're going through things, but it's bookkeeping, and it's easy to program. The way that this is going to get applied is we need some resolution to actually bin up our data. So we're going to pick how many rectangles we've got. In some sense, this is how you organize your data at home. I use shoeboxes for all my receipts for a year. And then on the side of it, I'm going to write, 2015 or 2016. It's the same sort of thing. We're going to have a grid cell that's where all the data for that area gets mapped. We use smaller ones than this, but that's the big idea. Now we have to have a traversal to go through them in order. And one way that I've thought of to talk about a z-order curve is every time we make a split, we're going to choose, when we choose left, we're going to put a 0 in the bit string. If we go down, we put a 0. And so now you could pick a cell here and come up with what the index is. So that's how you actually store the data. You pick wherever you are, and you say, I'm here, I'm in this grid cell. You find the address of that grid cell, and that's going to be some of the bits that you write out for the representation. In order to plan a query to get data back out, you're going to have to look at your gridding scheme that you've used and say, I want all the things here, I want all the things that are in this gray rectangle, and that's going to touch boxes that are a little bit bigger than your cell. So if we go back to my shoebox example, if I put all my tax receipts for 2015 in one box because I'm not that organized, if I need something from March, I've got to open up that box and sift through everything. Same sort of big idea here. So the plus side of using Accumulo, we have distributed processing that we can do in the iterators. So we can actually run code on each of our tablet servers and push down some of that filter processing. So if we were in a situation where we wanted to get back just the things in the gray box, and we also wanted just the tweets by a certain ID, or the cars that had a certain make, or whatever we were looking at, we could pass that filtering down to Accumulo so that we don't have to do it on our side, on the client side. Okay, so let's talk about how this scales up, because so far, most of what we've done is look at pictures of two-dimensional curves. They're pretty easy to work out and go through. My coworker, Chris Eichelberger, is great at making these fun little videos. And what we've done is this is just the 3D version of that row major approach, a z-order curve, and a Hilbert curve. And we can start to see that things are going to be bad for row major, a little better for z-order, and Hilbert's still got its nice locality properties. So this is just how things are applied in general. Let's actually work through an example of the building up a row ID, building up a key value pair for GeoMesa for actually where we are right now. So I went on Google Maps and tried to find a longitude latitude for roughly where the conference center is. I didn't find this room exactly. And it's 5 p.m. on a Wednesday. And what we're going to do is, in order to build up the key, we want to have a way of referencing space and time, but we don't want to just jam together time and space indiscriminately. We want to work through things so that we can actually get to our particular query range. One of the things that Rob had a chance to talk about is some of this binning or tiering that you can do by time, and that gets captured with this part of the row ID where we count the number of weeks it's been since 1970. Okay, so again, there's room to make this more general, but what we get as a benefit here is that this is going to work really well for most of the problems that we have to solve today. Okay. So we're going to use 2 bytes to reference what week we're in, and then inside of that week, so this is going to look a little bit like some application-based sharding you could already do with a database, where you start to store off separate databases for a month or a year. And the nice thing is we can do this already just inside our key value store, so we don't have to go to extra trouble elsewhere. In the next bit of the key, we're going to take a little bit of the X data, a little bit of the Y data, and the T that we're using here that we're blending together is 20 bits of information that represent where we are inside of the week. And then we can fold that together using a z-order curve. Okay, so, and I just list out some of the particular numbers for how we could actually get an Accumulo row ID that would reference where and when we are right now. So one of the things that I realized as I was working with some of the GeoTrellis guys, I was talking to Eugene last year at a code sprint, we realized that with this, with the grids, what's really happening is spacefilling curves are carrying, a 10 by 10 grid over to 100 indices or something like that. And if we thought about it the right way, there's some composition that could occur. So we could actually apply one spacefilling curve after another. This kind of scheme where we're going to run around in Accumulo and say, we've got this many bytes, this many characters that's going to represent something like what week we're at. And then we're going to go off and have other data that's going to represent a further refinement. Whenever you do that concatenation, you're actually doing a composition of a row major curve between whatever you've done in the lower bits. Okay, this is where things get to be fun because you've got lots of options. And again, my coworker Chris is good at these visualizations. He has a little web interface where you can say what compositions you want to work out. So the good thing about this is that this gives you some powerful options for how your data should be indexed and how it should be queried. With what we were talking about with the schema I just said, where we're going to say, okay, let's do something with a week up front, that's going to have an impact on your queries. If you've got a lot of short queries, it's going to make things faster. If all your queries are longer or have no temporal aspect, that index might not be so good. So it's apparent to me that these big data projects that Rob was just talking about, we need ways to be able to go back and forth, try things out, and also make comparisons about how our products are working out. So this is why we want the SFCurve to be a project where we can build a library in common, because otherwise we're going to repeat the same work in our 3 or 4 projects. Well, not GeoGenie, since they have a chance to actually use more complex indices like our trees. Okay. Great. GeoBench is a project where we're trying to answer some of these questions about what choices have we made and how are they going to come together. It integrates with the GeoTools data store API so that we could compare GeoMesa and PostGIS, for instance, if we wanted to. And it'll work for getting features out and also doing OGC requests like WMS against GeoServer. And as some example use cases, you might want to work with this in your own environment with your machines, whether you're using bare metal or AWS, and figure out what queries you're likely to run with your data, or run tests in some sort of continuous integration environment. The 2 cases that I want to talk about are if you're building a database like GeoMesa and you want to validate some difference you've made or understand some features and indexing choices, this gives you a chance to do that. And I want to talk through a possibility or 2 there. So if you remember the slide where we had that gray bounding box, there were some other shoe boxes we had to open. If we look in each of the shoe boxes, if we're returning the exact result set, this is slower because we have to apply some more filtering. If that gray box were just the viewport for our WMS client, we might not care. It might be okay to return all the results and let the WMS renderer deal with the fact that we got a few extra results. This is a trick that PostGIS does. And now we can just verify real quick, if we do this loose bounding box approach, is it actually faster across the experiments we ran? And that's what this slide is showing. Okay, one of the other things that we've done is we've created a new spatial index, and this is showing that's faster. And I'm going to go ahead and wrap up. This one's a fun slide, but we'll have to talk about it afterwards. Let me go ahead and wrap up and ask for any questions while I have 1 minute left. Yes?
For GeoBench, do you support any elements of chaos or variable requests, for example, to avoid overwriting your cache?
That's a good question. Oh, sure. So the question was, in GeoBench, do we have any methodologies to avoid dealing with caches being warmed up? And that's one of the things that we've thought about a little bit, and there's some ability to run the queries in random orders and deal with that. One of the things that's also going to happen is Accumulo does have index and data caching that happens. So if you were in a situation where you were trying to benchmark what happens as a user goes and looks in a particular area, those cache effects may be worth leaving in. And you do see that sort of cache where the first request can be a little bit slower than the other ones. Other questions? Yes? If you're trying to use both of them inside something like Spark?
Yeah.
Okay, so the question is, do you have to use the same index in order to bring 2 data sets together? And I'd say as you're doing that, you get into spatial joins, and that's, you should be very careful. In general, if you did use the same index, you'd be able to pull the same frames in Spark, and that would be the easiest approach for something like that. Okay, that's my time. Thank you very much.